What's up, everybody? Welcome to Code Arcade and welcome back to for some very interesting DSA problem solving. So today we'll be solving this very interesting and very efficient problem. So we'll be solving the 153rd problem in our list. So by the way, 153 is Armstrong number, and we'll be solving the find the minimum in rotated sorted array. So as simple as the question sounds, the question is very simple. So the input that we are given is we are given a rotated sorted array. So we're given a sorted array that has been rotated n times, okay, like this. So as you can see, this array is sorted in 1 2 3 3 4 5. It's sorted, but the elements inside the array are rotated n times. We don't know how many times it is rotated. We are just given the array as an input, okay. So note, given the array as an input, we need to determine the most minimum element in this array, okay. So the question is very simple. We just have to return the most simple element, the most minimum element in this array. So as simple as the question sounds, it is not simple as it is to solve, because here they have mentioned a very important line here that anyone knows that this could be done in order of n. You just loop through the entire array, and you can just iterate the array and just find the minimum and just return it, boss. What's the big deal? So you can ask, what is the big deal here? But the big deal is you have to do it in order of log and time complexity, okay. So you have to use an algorithm to solve this problem in order of log and time complexity. So see you guys in the logic. Here in the logic, the logic is simple as a solution sounds. So simple as a question sounds. So here, as we are given an array like this. So as you can see, when we observe this array, that we can spot the minimum element is 1, correct. So the original array will look something like this, no, will look something like 1 1 2 3 4 5, will look something like this. But this is sorted two times, this is rotated two times, okay. So it appears to us like this. So we need to find this one in log n time complexity, okay. So when you hear this word log n, and when you hear the word efficient problem, we always think of algorithm called binary search, okay. So that's what we're going to be doing here today. But you may have a question. The binary search algorithm only works in a sorted array like this one. How could you solve this problem in a binary search algorithm, but when it's rotated like this? So that's what we're gonna do today here, okay. So hold on to me, just bear with me for a minimum. So this is our array, okay. So as we all know, the binary search algorithm has three main pointers: the start pointer, the end pointer, and mid pointer, okay. Each time, it's the binary search algorithm, when it's sorted, it is very easy, because we have to find we'll check if the target value is in the left hand side or in the right hand side, correct. So but here it is a little bit tricky, because the target value is actually the minimum value, okay. So let's say, for an example, this array is not rotated. If it is not rotated, then we can straight up say 1 is the minimum. The If it is not rotated, since it is sorted, then the 0th index element will be the minimum. So you can just return the 0th index element. But here in our case, it is rotated. So what we're going to do here is, when you see this when you see this whole array, we can spot we can separate this array into two main categories, okay. So bear with me. We can separate this array into two main categories. So let me just do so. So if I separate this part alone, okay, this two elements alone, if I just separate it, you can see that we are able to form a you can see that this tells us something, okay. So now what does this, when I separate these two like this, what does this tell us? Here you see the left hand side of the array, it is sorted, and the right hand part that we separated is also sorted. But here, if you check this part, this 5 1 and 2, it is not sorted, correct. So there is a pivot somewhere here, okay. Pivot is a point where the array is not sorted, okay. This 5 and 1, this is a pivot point, okay. So you can find a pivot here. The elements before the pivot are sorted in ascending order, and the elements after the pivot are sorted in ascending order. But here, in between the two elements, in between the pivots, the elements are not sorted, correct. So you can find this pivot. So our minimum we can either be on the right hand side of the array or either the left hand side of the array. Okay, this is what we know so far. But as per this image that we are seeing now, we can tell that our the element we are searching for, which is 1, it is in the left right hand side of the array, correct? So now how do we find this one in a log and in an efficient way, not traversing through the entire array? Okay, so as per let's do the binary search operation once. Okay, here we have the start pointer, end pointer. I calculate the midpoint. Okay, the midpoint will land up on 5. Okay, so now with this 5, what do we know? How can we find if? Okay, we know one thing from this problem. Okay, so as bear with me, as we are calculating the midpoint, the midpoint will land up either in the left hand side of the array or in the right hand part of the array, which is sorted. Okay, so now let's say it is in the right hand side. It is in the right hand side, left hand side of the array. Okay, now the logic behind this is, wherever the midpoint is landing, that the minimum element will always end up on the other side of the array. Okay, now the midpoint has landed in 5. Okay, now what we know is the smallest element will always end up on the other half of the array. Okay, now how do we know this? Okay, and how do we find this? So let's say we have the midpoint. Okay, now let's take the starting pointer. Okay, let's check if the element which is corresponding to the starting pointer is less than the in the midpointer. If it is less than the, then the from the starting pointer to midpointer is sorted. Okay, and if it is less na, then the element that we are searching for is not in the left hand side. Okay, this is what we know. So what we do is we immediately move our starting pointer to mid plus 1. We move it here. Okay, we move the range to the left hand side. Now we calculate the mid. Okay, what are the indexes? 0, 1, 2, 3. 3 plus 4, 7. 7 by 2 is 3. So midpoint will end up here. Now what we do? Now here, now we came to the correct part of the array. Okay, now here what we do is we don't check if the midpoint is our min or not. Okay, we don't want to check that. We check if the current value that you are sitting in, the current value the start point is sitting in, is it actually less than the end pointer? If it is less than the end pointer now, then this is not the pivot. Okay, and this is not a pivot for this part of the array. Then if it is less than, then we immediately found our min, because bear with me, because here in this part of the array, this is the smallest element. This is the minimum element that we could find. If this part is less than, if the starting element is less than the ending element, the very last ending element, then this is the minimum. Okay, we're not going to leave that as the minimum. Okay, we're going to just update it. So what we're going to do is we're going to follow this method. Okay, so let's say we're going to follow this method. Let me just repeat the logic once again so that you get it clear. Okay, so I'll have a resultant variable to keep track of the minimum. Okay, so here, as from the starting, okay, let's take it step by step. Okay, the first step that we're going to do is we're going to find the minimum. Okay, we're going to find the minimum, and then what we're going to do is the logic what I'm about to say right now is to find which part of the array is the minimum element presented. Okay, so as we know, as we have two parts now, what we know is whichever part the mid ends up in, the midpoint ends up in, the minimum is in the opposite part of that array. Okay, so if the mid element ends up here, okay, if the mid element ends up here, so let's say this is rotated again. Okay, let's say this is rotated like what do we say, it is rotated like this. Okay, so now if we take this mid, as we saw the element, as we take this middle pointer ended up in 5. Okay, as per our logic, the minimum element ended up in the other side of the array. Okay, this is what we know. This logic is only to find where the middle element is. Okay, where this is where which part of the array the minimum element is. After we go to this part, okay, after we move the start pointer to this, we're not going to use this logic again here. Okay, here instead what we're going to do is we're going to check if the starting element is less than the ending element. If it is less now, then definitely the starting element is the minimum element, because this is the first element present here. Understand? So the whole thing is we're gonna find which which thing the minimum, which part of the array the minimum is in, and then we're gonna check if the starting element of that array of that part is less than the ending element. If it is less now, then it's definitely the minimum. Okay, this is what we're gonna do. Okay, so let's start coding right away. Okay, just bear with me. If you don't understand the get the logic properly, get it when I'm coding. Okay, so as per a tail, let me have my resultant array. So it's gonna be okay. Let's just declare our resistant res array over here to keep track of the minimum. So I'll just have it initially at nums of 0, this initial value. I could have it anything, doesn't matter. Okay, so the next part that we're gonna do is carry on to the first step. So first as usual, so let's for to start the binary search, let's just declare our start pointer at 0, end pointer at len of our nums -1, and let me have my while loop going while. So my as per our binary search, my while loop go going going until start pointer is less than end pointer. So let me just have a semicolon, and the thing what we're gonna do inside the binary search is, so first, as I told you, have to find the part of the array. Okay, as per we saw here in our drawing, you have to find this part. Okay, so first after that we find this part, we have to check if whatever part we are binary searching through, whatever part we are checking now, we have to check if the start index is less than our end index. If it is less than, then we found our minimum number. Okay, then we found our minimum number. So let's just check that real quick. If our start pointer, no, nums of start, this is just an index, so nums of s is less than num nums of end pointer, this means that we have found our minimum number, correct? So let's just return our, no, instead of returning, we can just update this res variable with, we can just update the res variable and keep tally of the res. Okay, so let me just have my nums of r. So it's going to take the previous res and then compare it with the res. Let's just say first we are just going through this part of the array. If we are going this part through this part of the array, then 3 will be the smallest value, so that will get updated to res. But here we just have to keep the tally, so nums of yes. Okay, so good. So when the code reaches this line of code, then it means that we have found our minimum value, so we just need to break out of here. Okay, we just need to break out of here. So let's say we didn't, let's say it is not, then we have to find the part where the minimum value is in. So I'll have my condition here. If my, I'll just calculate the mid first. So mid is equal to, as usual, s plus e divided by 2, correct? So let me just check that condition real quick. So the condition is, if our nums of mid should always be greater than or equal to, if it is greater or equal to, let's say in our case here, if the nums of mid is greater than or equal to this our start, correct? Nums of end, one second, yeah, nums of our ending pointer, we have to check until the starting pointer. Sorry, if it is greater than or equal to the starting pointer now, then we just have to move our starting pointer to mid plus 1 as per our logic. We're just moving the window. Okay. Now next part is if it is not greater means if it is not greater else we have to move the ending pointer to mid. Okay. We have to move our ending pointer to mid minus 1. Sounds good? At the last, after I calculate the mid, I'll just put another condition here, statement here. Each time, I'll just check if the mid is the minimum value. So there are cases that the mid can be the minimum value. So I'll just check if the mid is the minimum value. So between the old res and the new nums of mid. Good. Sounds good. So keep tally of this. At the last of the loop, end of the loop, I'll just simply return my res. Okay. Looks good. Sounds good. So let's just see if all the test case pass. As per we guess, all the test case pass and we made 100% of the fixes. So thank you for watching, guys. So if you don't understand a little bit, just rewind and see what I told. Okay, little bit a tricky problem. So we'll see upcoming problems like this in our future videos. So thank you for watching. See you all in the next one. Bye.